Chapter 25, Fluid Balance, Screencast 4. Now, this screencast will be focusing on how the body actually regulates fluid balance. And there are going to be three variables that come into play when fluid balance is being managed. We need to be monitoring blood volume, blood pressure, and blood plasma osmolarity or plasma solute concentration. Now, keep in mind, especially when we look at volume and plasma solute concentration, these two are very much related to each other. If we change one, the remaining two variables will be impacted. So let's take a look at the relationship between these three variables. If fluid intake is less than output, this will result in a decreased blood volume and a decrease in blood pressure. This will end up increasing plasma solute concentration if more water is lost than solutes. If fluid intake is greater than output, we will see a corresponding increase in blood pressure and blood volume. This will result in a decrease in blood osmolarity or plasma solute concentration if the gain of water is greater than the gain of solute. Now, when we look at regulating fluid intake, this is going to be due to activation or inhibition of the thirst center, which resides within our hypothalamus. The first thing that we're going to look at are those things that actually will stimulate the thirst center and cause us to drink or consume more fluids. The first will be decreased blood volume and blood pressure. In this situation, renin will be released from the kidneys. This will result in the production of angiotensin II. Now, this is a result of the renin-angiotensin pathway, and that pathway will be addressed to a greater degree in the final fluid balance screencast. One of the things that angiotensin II will do, it will stimulate the thirst center. The second is an increase in blood osmolarity or plasma solute concentration. This could be due to insufficient water intake. This will directly stimulate the thirst receptors within the brain, and the hypothalamus will be triggered to actually release ADH or antidiuretic hormone. The third and final stimuli that will activate the thirst center is a decrease in salivary secretions. The sensory input is relayed from the receptors that actually reside within our mucous membranes and will end up activating the thirst center, causing us to drink. Kind of imagine you wake up with your mouth really dry, and one of the first things you want to do is grab a drink of water just because you feel so dry. All of your mucous membranes have dried out. Now, there are going to be stimuli that inhibit the thirst center. This is when fluid intake is greater than fluid output. First, increased blood volume and blood pressure. This will actually inhibit the kidneys from releasing renin, so there will be a lower amount of angiotensin II, and that results in a greatly reduced stimulation of the thirst center. There could be a decrease in blood plasma solute concentration or osmolarity. In this situation, the thirst center is no longer activated directly, and decreased stimulation of ADH. There could be an increased salivary secretions, so now there's going to be a decreased sensory input to the thirst center. And last but not least, distension of the stomach. This is not something we saw previously that actually activates the thirst center, but kind of imagine when you're drinking fluid, the stomach will stretch, baroreceptors within the stomach will be activated, and this sensory input will basically inhibit the thirst center. Now, the next thing that we have to address is the actual regulation of fluid output. Now, this is going to occur through renal function, and remember, our kidneys are the organ that are responsible for the output of urine. There will be a total of 4 hormones that play a role in regulating how much urine is being produced and excreted. Those hormones are angiotensin II, antidiuretic hormone or ADH, and aldosterone. The activation of these hormones will decrease urine output to increase blood volume and pressure. the remaining hormone, atrial natriuretic peptide, this will actually increase urine output to decrease blood volume and pressure. Now, please take a note at something going on here. There are actually 3 hormones that come into play when we see a drop in blood pressure, whereas there is only 1 hormone that comes into play when we see an increase in blood pressure. So please keep that in mind, because if you think about it, if there are more things that regulate a particular variable than the other, the body must take that more seriously. And that's the case when we're talking about a decrease in blood pressure or blood volume.